2019 paper. Okay, trigonometry question. Okay, let's read the question first. They were given figure shows 4 points A, B, C, D on a level ground. Okay, D is located south. D is located south of A, B. A. Okay, D is located south of A. And B is located east of D. B to east of D, C. Okay, I'll read again. B to the east of D and C to the south of B. Okay. This is east and this is south with respect to each and every angle. Okay, if this is south, this is east, the angle in between them. Okay, these are perfect angles, no? So that means we know that in between major angles, the angle deviation which is 90 degrees. So this is a right angle and this one also a respective another right angle as well. Okay, now we have two right angles with us. Okay. Then after I'll read the continuation of the question. The bearing of B from A is 145. Okay. B from A means from A you should draw the north. From that the bearing means from north how much angle which is deviated. This is given as 135 degrees. Okay. This is 135 degrees. That means we know over a straight line the total angle occupied by a straight line which is 180. From that when you subtract 135, remaining is 45 degrees. Remaining angle, this is 45 degrees. Okay, if this angle is 45, this one also should be 45 as well. Accordingly, we have to determine what are the values we need to find. Okay, in your book, in your paper, you should copy this diagram and denote these angles and lengths. And AD is 20. Okay, AD means this length which is given as 20 meters. This is 20 meters. Okay. I'll guess if it is 20, this one also would be 20. Okay. That's my conclusion because these two angles are same. No. So this is an isosceles triangle. So the side opposite to this 45 and side opposite to this 45 both should be same. So this angle also would be 20 meters. 20 meters. And DC 42 meters. DC is 42 meters. This is the given data in DC triangle which is 42 meters. Copy the given figure onto your answer script and include the above information in it. Using trigonometric ratios, you should find the distance dB. Okay, without using that. Sorry. Wait. This is not 135. This is 145. If I made any mistakes, just let me know. Sometimes I will misconclude something. Yeah, this is 145 degrees. Sorry. If this is 145, this would be 35 degrees. This is 35 and we know AD is 20. AD given as 20 meters. By using trigonometric ratios, we have to find BD length first. Okay, BD length first. So that means we can use any of those theorems. Okay, any of those trigonometric relationships to find that one. That means here we have the angle which is 35 with respect to this 35, this dB which is opposite with respect to this 35. This is our opposite side. Okay, this is our opposite side, and with respect to this 35, when I consider about this triangle, this is our adjacent. Okay, adjacent side and opposite side. Now we have both. So we have to write the relationship in triangle ABD. In triangle ABD, what's the thing we have to find first? We have to find the length of DB. Now, for that, I am going to write this is opposite, this is adjacent. That means the angle we have to use, which is tan 35. Tan 35. Tan means opposite side upon adjacent side. Opposite side upon adjacent side. Tan 35, we have to use table, and opposite side, which is DB, that's the thing we need to find. And adjacent side, we already know adjacent side as 20 meters. And by using the tan table. Let's find what is tan 30. Okay, this is our table, but here you should perfectly find what is our natural tangents. Okay, natural tangents. In tangent table, you should find tan 35 degrees. Okay, tan 35 degrees means this one. In 35 row and 0 column. So that means 0.7002. This is our tan 35 degree. In natural tangents table, you should find what is tan 35. That is 0.7002. Okay, now we have our tan 35 0.7002. Okay, 7002. What is our question? To find the distance dB to the nearest whole number. Nearest whole number. So when we multiply this, dB would be the multiplication of 20 with, okay, we have to cross multiply this. That's all. 0.7002. That will give you dB as, okay, dB as 14.004 meters. The question is, okay, mostly students will not read the question clearly. Find the distance between dB to the nearest whole number. Nearest whole number means, so nearest whole number which is 14. So now we have dB, okay, dB which is 14 meters. Now we found this one as 14 meters. Okay, now we have that one with us. Now let's read the question again. Whole number and show 2 BCD greater than DAB. 2 BCD greater than AB. Sorry, DAB. BCD means BCD. This angle. DAB. That is 35. Okay, DAB 35. We already know DAB as 35 because in the question this is 145 from 180. When we subtract 145, remaining DAB, that is 35 degrees. We already know that. So what we have to find? We have to find BCD angle. In the below triangle, we can use trigonometric relationships to find BCD angle. BCD means this angle. Okay, I'll denote it as simple C. Okay, simple C angle. So in this triangle, we have two lengths. Okay, we have two lengths. By using those two lengths, we can find the angle easily. Okay. Now I have to write again in triangle BCD. In triangle BCD, this is the angle we need to find. The sides which we have with respect to this angle. The 14 is opposite side and 42. 42 that is opposite to right angle. Opposite to right angle. So this is our hypotenuse. Hypotenuse of this side. So opposite upon hypotenuse that would be sine. Sine C. Sine C is opposite upon hypotenuse. In triangle, in the below triangle, look at this carefully. In below triangle, opposite side is 14, hypotenuse is 42. When we divide that, okay, that will give you 0.3333. 0.3333. Okay, you should keep it up to your fourth decimal point because in tables we can use that one up to fourth decimal. So here the angle we have to find C. Okay, this angle. So now we know its respective sine value, but what we only need this angle. So for that, I'm going to inverse this function. Sine inverse 0.3333. Sine inverse 0.33. That means what we have to do further than this? In sine table, okay, in sine table you should check. Inside the table you should check where is this 0.3333 is located. That's our angle. Okay, in natural sine I have to check whether where is our 0.3333 exists. 0.3338, but that is greater than our requirement. Our requirement is to find 0.3333. Okay, 0.3333. I'll try to 3333. But here we have 3338. 3311 we have. Okay, 3311 we have. Okay, that is 19 and 20th minute. Okay, in 19th degree, 20th minute we have 0.3311. With that, when we add the mean difference as 22, mean difference as 22. Okay, I'll write this one 0.3333. We can separate this one as 0.3311 plus when you add 22. Okay, with last two digits you should add the mean difference. That will give you 0.33, so we have to find its corresponding angle values. So 0.3311 and 19 degrees and 20th minute. 19 degrees and 20th minute and 22nd 22. The mean difference 22 is located in 8th minute. Okay, in 8th minute. In 8th mean difference. So when we add this, that will give you 19 degree and 28 minutes. 19 degrees and 28 minutes. Okay, now we found our C angle. Okay, angle C. Okay, I'll write over here angle C as C means this angle. Okay, this particular angle BCD, angle BCD. We found that one as 19 degrees and 28 minutes. 19 degrees 28 minutes. The question is that to show 2 times BCD, double of this angle which is greater than 35. Okay, double of this angle which is greater than 35. Now let's find what is 2 BCD angle. 2 times BCD. When we multiply this by 2, that will give you 38 degrees and 56 minutes. If the minute value extend over 60, you should keep that one as a degree. You know that. Okay. So 38 degrees 56 minutes, and the angle we need to compare, which is DAB. We already know that DAB is 35 degrees. This is greater than 35 degrees. This is greater than 35 degrees. Question is easy. I'll recall the question from the beginning again. First of all, this is the bearing is given as 145. By using that, I found this one as 35. We have an angle and side. By using that, using tan relationship, I found the intermediate length BD, which is 14 meters to nearest whole number, which is 14 meters. In the below triangle, we have this is 14 and this one is 42. So the sides we have are opposite and hypotenuse. So relationship we have to use with is sine. So sine C is 0.3333. So C angle would be sine inverse 0.3333. So we found the C angle as 19 BCD angle by using sine table. We found that respective angle as 19 degree and 28 minutes. The question is that to show 2 times BCD, we found it as 38 degrees 6 minutes. That one should be greater than DAB, which is 35. So likewise, you can finally show your answer like this: 38 degrees 56 minutes, which is greater than 35 degrees. That's all.